So my name is Abbassi. I am a technical evangelist for Algorand. And today my talk will be on using IoT blockchains, in this case specifically using Algorand. So here's just some members of the team. Amy's based in Boston. She's one of our community organizers. Russ is another tech evangelist. Myself, Silvio, he's our co-founder. Liz is one of our product managers. Evan's in the back, one of our engineers.
Hi everyone.
Okay, this is our safe harbor statement. I'm not sure if you guys actually have to read that, but it's there. Okay, so by the way, we have a competition for YubiKeys. Well, not a competition, it's a lottery. So if you just scan this QR code, put in your email, and/or fill out a survey, I'll give these out at the end. By the way, just like full disclosure, and I'll go into this later. We're trying to figure out what our developer market fit is. This is all in that effort, in the sense that we can go after more standard crypto developers, more of the Ethereum mindshare. Or we can go after non-blockchain developers, given that we have a suite of SDKs in pretty much every modern programming language. So this is part of our effort, coming to conferences, talking to everyone, going through these surveys. So these are dev docs, and dev docs are at developer.algorand.org, actually. And our SDKs can be found at github.com/algorand. These, I don't know if anyone here is participating in our hackathon API challenge, but first place is $1,000, a co-drone, and a tool backpack. It's one of my personal favorite types of backpacks. Everyone's got one on. And then second place is a Gotenna Matrix Creator and a Raspberry Pi. Should get plus here. Matrix Creator is like an IoT device you can put on top of the Raspberry. Humidity sensor, temperature sensor, accelerometer, gyroscope. It's awesome. These are actually, so this is a Matrix Creator. Gotennas are for mesh networks, which are great. I don't know if you guys know how that works, but basically a Gotenna communicates with another Go antenna through radio frequencies. So this type of product is designed for emergency situations, more of the fringes with respect to internet access. And you have an app on your phone that talks to it via Bluetooth, so you don't need any cellular connection, any Wi-Fi, anything actually. So are most people here familiar with blockchain? Is anyone new? Okay, great. So this is kind of redundant, but tamper-proof, transparent, and there should be some sort of trustless, trusted environment. This is kind of a term, like a lot of terms in the blockchain space, that's quite ambiguous, right? So it's a very nascent industry. So things like decentralization, things like immutability, even things like trust, ebb and flow in terms of what people mean when they use it. So trust is a really important one, or trustless trust. So yeah, so again, this is more of the general blockchain high level, but our centralized economies are clearly broken for a multitude of reasons, and we're here to try and fix that as best as possible. So what is Algorand? So Algorand is a pure proof of stake blockchain. I'll go into that in a second. We are permissionless. We have very fast transaction throughput and finality. It's pegged at about 1,000 TPS. Less than 5 seconds to create a block. And there is no forking in the sense that the network itself, consensus-wise, can't split mathematically. And with this type of design and type of architecture, theoretically, we can scale to billions of users at a much quicker pace. Adoption is also part of that whole process. So the way our consensus generally works is through a process called VRFs. So is everyone here familiar with ZK snarks? Was your knowledge proofs? Probably heard of it. Sure. So Silvio, our founder, was actually one of the authors of zero knowledge proofs, one of the pioneers of cryptography, actually. So VRFs are kind of a derivative of ZK snarks in a way, and that gives us our very fast transaction throughput. What's basically happening is that every account that has algos in it, I'll actually read this just to make sure. It's really good. So the VRF output, when executed for an account, is used to sample from a binomial distribution. So to emulate a call for every algo in a user's account. The more algos in an account, the greater chance the account has of being selected. It's as if every algo in an account participates in its own lottery, right? So with respect to the decentralization, what I mentioned earlier, the Bitcoin space, for instance, talks about decentralization with respect to validating all transactions in the network. Like, if you're a participant, then you should be fully validating every single transaction that's ever happened in the network, that's happening now, and that will continue to happen. When we mean decentralization in this case, you're incentivized to run a node. Because if you're participating in the economy for integrity reasons, you want to make sure that your copy is or maintains its integrity as best as possible. But what we mean in this case is more of economic decentralization. Whereas even if you have more algos or more wealth than someone else in the network, you have as much of a fair chance to be able to not only get rewards and right to the blockchain, but also vote on who is the person who gets the rewards and who gets the right to the blockchain. So consensus in that case is decentralized. This is more of our consensus. So generally, one account is chosen to propose a block, and then a committee is chosen to vote on that person of around 1,000 people, give or take. Sometimes it's more, sometimes it's less. And once that committee votes, then it's written to the blockchain. So it's practically very hard to break this consensus and break this model mathematically, which is why we say that it's unforkable. So we have the Algorand Foundation as well. The Algorand Foundation runs a monetary policy, does the token offerings, the auctions, and sets up the whole reward policy. Algorand Inc., who I work for, Evan works for, is contracted by the Algorand Foundation to build and maintain the infrastructure of the blockchain network. We have testnet. Testnet's awesome. It's quite distributed. So obviously, I recommend that you first build a devnet, then testnet. So we have our own devnet, kind of private net that you can build. Testnet and then to mainnet. But testnet's fantastic. Testnet's been up for about Evan, what, a year and a half?
Yeah, year and a half or so.
By the way, our mainnet's only been live for 2 months, so part of this is prototyping. So APIs and command line tools. So we have two main processes. There's AlgoD and KMD. AlgoD maintains the integrity, or runs the protocol, rather. And KMD is more of the wallet process. So there's no consensus process happening in KMD. That's more meant for like air-gapped wallet development for wallet developers. Goal is our command line tool. IO keys are standalone command line, and we have a bunch of SDKs that I'll go into in a second. So that's just a bigger overview. We have things like Clerk and Ledger. Clerk allows you to send multi-sig and even raw send. Here's some of your KMD functionality. So SDKs and Swagger. So we use Swagger to describe the structure of our APIs. This is on swagger.hub, and sample code is generated for your language of choice as well. So our SDKs are written in Go, JavaScript, Java, and Python. Now again, this was designed to make it as easy as possible for a non-blockchain developer to get into this. I know when I was getting into blockchain, Ethereum was obviously the lowest barrier to entry because it's so similar to JavaScript, how it reads. But at the same time, it's still a barrier to entry because I had to learn a new scripting language. Now that's a very strange thing in the space because I think for Ethereum developers, Solidity is like a central tenet. It's like it's a unifying factor in who they are and what they know as a community. We're taking kind of a different approach currently, where we have SDKs in the most modern languages. But yeah, so you have your KMD wrapper, your AlgoD wrapper, and again, KMD is meant more for air-gapped applications. Yes.
It's just when you say air-gapped applications, could you explain that a little bit?
Yeah, and that's meant to be run offline entirely. So more for wallet development, some different precautions. So these actually, I'll just show an example, and I'm going to go into my IoT example in a second. But just to show you what it looks like. So we don't have smart contracts as of now. The objective is to have smart contracts in a year. We're actively working on it now. Opcode development, just general strategy and planning. So it's not just a roadmap item, we're actually working on it now. But the way it works currently is that inside of a transaction, an Algorand, inside of a transaction object, you have a field. One of your fields is called a no field. Inside that field, you can write about a kilobyte of data and then commit that to the chain. So you can run all your logic off-chain, and then almost like a timestamp if you're going to use that as your on-chain record. So this is what this looks like in the SDK. So you have, these are the different fields you can have in a transaction object. This is the Python SDK, by the way. So sender fee, first valid round, last valid round. This is the no field that I was talking about. Genesis ID and Genesis hash. I just want to show you what that looks like. I'm big on visuals. I think it helps. Here's an example. So writing a transaction to a file. So you can do a couple things. You can get suggested params here to make it easy. But you see here, you don't even need every single parameter that I just showed you to write a transaction. For instance, in this case, you're just writing a simple transaction, so they don't need any note field or any kind of data in the note field. So that's just not included. But it's quite straightforward. And a transaction to write to file is what happens. So here, and then this one is actually working with the note field. So this is what that looks like. you can define it here. In this case, we're doing an option. But in notefield.bytes, that's passed in. You have to encode it, .pack, and then you can add it into your transaction object here, and then sign it about this. And then near-term projects. So these are our near-term projects that are coming up. Vault is meant for almost like validating block headers in Bitcoin. It should make it easier to host your record of the blockchain and to validate, incentivizing more people to run nodes. That's what we will do want. These are atomic squared swaps. So this should allow you, or it should make atomic swaps a lot easier in the sense that you wouldn't have to do these small steps to prove that you, or to basically mitigate your counterparty risk. In this case, you should be able to do atomic swaps in one go. And then smart contracts are what we talked about earlier. So you can become an Algorand ambassador. We also have Nate here from PureStake. So PureStake is kind of like our Infura service. You can basically make API calls to the remote instances. They have different plans here. And so let me then plug this in and show you how the Raspberry works. So I just made it very, very simple, and I'm not a hardware engineer, so it may look impressive, but it's not necessarily. It's very easy to do. I made a simple IoT device using our Python SDK. Show how that works. While that's booting up, has anyone worked with the Raspberry Pi before? Yeah? Okay. So what's great about Raspberry Pis is that, well, they're incredibly versatile, obviously. So this is an RFID reader, RFID scanner. I have this, so the Pi itself is a single board computer, but they have GPIO pins, which are general purpose input-output pins. So you can pretty much plug anything you want into it. In this case, I have what are called two breadboards. There's just pins at the bottom of it that allows you to set up circuitry properly. I just have all these pins attached to this one. These have a bunch of labels, so it's easier for me to plug things in and out. And then I have these plugged into the wires on this breadboard that's attached to my RFID scanner. And these have different functions here, so you do have to plug in the right function to the right corresponding pin. This was an awesome project, honestly, because I've never actually had to what's called solder, like melt pins into a board, which was awesome. I've never done that before. It was incredibly fun. So let me show you first where you can find all this. So this is Raspbian, by the way. This is Raspbian OS. In Raspberry Pis, you can basically mount different operating systems on different micro SD cards and swap them in and out of your Raspberry Pi, making it, again, incredibly versatile. So let's see for a second. So you can find, I'm going to publish my code today, but you can find the README at least here, and I'll walk through that with you in a second. Let me get this set up. Terminal. Bear with me, my keyboard's a bit glitchy. It's really good to travel with, but it's not exactly the best when it comes to public thing. Okay, cool. Build this up. Right. So let's go to our RFID project. Let's go to, okay, so let's just actually get started. I'll run it once and we can talk about it. So I have some RFID tags, and so these have hard-coded IDs, and you can match that up to your application, or you can write data to it. So right now I have a hard-coded account that it's going to read from. So this one I believe is going to read my balance. Yeah, so my account, that's how much I have in my account right now. This one should read my pending rewards, I think. Pending rewards, currently 0. And then this one should read my total rewards. Yeah, so these are my total rewards. So all this is doing is making requests via the Python SDK to a remote instance I have running. You can also run a Algorand node using a Raspberry Pi, or I already have, it's very simple. But in this case, I wanted to show how you do it using the remote instance. So now we can grab this account, go to the Algo dispenser, make the audacious claim that I'm not a robot. Okay, so here's our confirmation. I'm going to jump back in here. So this should now read 9,000. So that's the change. Goes pretty fast. Versus this. Now we had a patch in testnet, so there's a bit of a glitch in the rewards. So it wasn't working earlier. I have a feeling it's not going to work now. It's probably going to read 0. That typically should change. It's just a patch in testnet that we're going through right now. And our total rewards, again, should change as well, but because of our patch, it's not going to. But that's basically how this works. It's very simple. What I wanted to do with this, or what I might do ultimately, is put it on some sort of moving object, like a toy train, right? So you could basically prototype the idea that different tags on the track will represent different stations. You can run I can paste the RFID reader under the train, and then it can read each tag as it goes along. But with our really fast transaction finality, things like this are possible. It's kind of weird. So let me show you the code. So you can see how that works. Okay, so what's important really is this from Algo SDK, transaction, mnemonic, account, you need your Algo client. This was me sort of tinkering around and trying to do some other stuff. And so here's where you declare the URL, your token for AlgoD. And then the next relevant line with respect to Algorand is down here. So this is what you're defining what you're calling from the SDK. Your account info, you want your address, your pending rewards, your amount, and in this case your total rewards. So really just in 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 lines of code or so, you can make some basic functionality. So the next thing obviously is the post transactions using the RFID tags. But yeah, this is a very simple prototype of how you can build an IoT device using a blockchain network. Are there any questions? All good? Okay, thank you.